class we were studying about Aufbau's principle. Aufbau's principle states that the orbitals will be filled in the increasing order of energy. So we drew one diagram for that. Okay, the increasing order of energy diagram. So which orbital will be filled first, that we study. Okay, so next we are going to study about the Pauli's exclusion principle. Pauli's exclusion principle. Pauli's exclusion principle. So what does this Pauli's exclusion principle say? Let us study with the help of one example. Suppose there is one orbital like this. Okay, and considering this is s orbital of the first shell. First shell means what? It is 1s orbital. Okay, so in that two electrons are there. In that two electrons are there. Now you say what will be the n value? First shell means n value will be 1. Yes, s orbital means L value is equal to 0. Okay, for this electron, let me keep this one as first electron and this one as second electron. Okay, so for the first electron, it is in 1s orbital. So n value is 1 and L value is 0 because it is s orbital. And what will be the m value? M value will be 2L plus 1 values. 2L plus 1 values means 2 into 0 plus 1. So how many values will be there? 1 value. What will be that 1 value? M is equal to 0. So for the first electron, N is equal to 1, L is equal to 0, M is equal to 0. Now what is the spin? It is in the clockwise spin. If you put the symbol straightly, it is clockwise spin. So clockwise spin means S value will be plus half. Now for the second electron, it is also in the first shell. So n value will be 1. So it is the s orbital. So L value will be 0. M value, what will be the M value if L is equal to 0? M value also will be 0. But what about the spin? It is in the anti-clockwise spin. So S value will be minus half. So what this Pauli's exclusion principle is telling is both the electrons cannot have the same set of quantum numbers. Cannot have the same set of quantum numbers. Even though three quantum numbers values are same, the fourth quantum number value will be different only. No two electrons can have the same set of four quantum numbers. So right, no two electrons can have the same set of four quantum numbers. Can have the same set of four quantum numbers. So this is only called as Pauli's exclusion principle. Now the next one we are going to study Hund's rule. Hund's rule. The next one is Hund's rule. Hund's rule, what it is telling. First I will explain with the help of one example. Suppose if I take a p orbital. You know what is p orbital? How many types are there? 3 types. Px, Py, Pz orbital. Px, Py, Pz. So maximum how many electron it can hold? Here 2, 4, 6. So maximum I can have 6 electrons in the p orbital. Okay. Suppose if there are only 4 electrons, how you will fill that? There are two ways in which you can fill. So first way, you see how I am filling. Suppose if I am having only 4 electrons, okay, how will you fill the 4 electrons? There are two ways. You see the first way how I am filling. Okay, see the first way, 4 electrons. So 1, 2, 3, 4. This is one way. Okay, this is my first way of filling the electrons. Now see the second way how I am filling. So if it is like this, see the second way, 1, 2, 3, 4. So 1, 2. First I filled this box fully and then I went to this box. Here what I am doing, first singly I am filling all the boxes, then only I am starting the pairing. Which is the correct way? This first way is the wrong way, the second way is the correct way. So when you fill the electrons in the orbitals, first you should fill the electrons in a single way. In a single way. First you should fill all the orbitals with single electrons. Then only you should start the pairing. Okay, so Hund's rule states that pairing will not occur unless all the orbitals are filled with single electrons. Okay, so pairing of electrons in an orbital does not occur until all the orbitals are filled with single electrons. All the electrons are filled with single electrons. All the orbitals are filled with single electrons. So Aufbau's principle, Pauli's exclusion principle, Hund's rule. All the three are very, very important. Okay. So the next one we are going to study a very important topic which is called as electronic configuration of atoms. Electronic configuration of atoms. Okay, how will you find the electronic configuration of atoms? That we are going to study. So yesterday we studied the order of the filling. Yes or no? So how will you fill oneness? First you have to write all these things. 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, then 5s, 5p, 5d, 5f, then 6s, 6p, it will go on. Okay, so first what I should do? I should cancel all the orbitals diagonally like this. Okay, diagonally like this I should cancel. Then what I should do? I should put a downward arrow mark in all the lines. Then I have to connect it like this. I have to connect it like this. Okay, so which orbital you should fill first? 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then after 4s what will come? 3d, like this you will fill. Okay, so in s orbital maximum how many electrons? 2 electrons. P orbital maximum how many electrons? 6 electrons. D orbital maximum how many electrons? 10 electrons. And in F orbital maximum how many electrons? 14 electrons. Suppose if I want to write the electronic configuration of carbon. What is the atomic number of carbon? Carbon's atomic number is 6. So in your lower classes you would have studied 6 means 2, 4. Like this you would have studied. But in 11th standard you should not write like this. You have to write with the help of orbitals. So which is the first orbital? 1s. So I should write 1s. In s orbital maximum how many electrons can be there? 2. So put this as power 1s 2. Like this you have to read. Then after 1s 2s. 2s s orbital maximum how many electrons? 2. So 2s 2. So 2 plus 2 4. After 2s you have to write 2p. So already 4 is there. In p orbital maximum 6 can be there. But already 4 we have filled here. Remaining how many is there? 2. So 1s2, 2s2, 2p2. This is the electronic configuration for carbon. For sulfur shall we write 16? What will be the electronic configuration? Tell me. 1s maximum 2. Then afterwards 2s maximum 2. Then 2p maximum 6. 2 plus 2 4 plus 6 10. So totally 16 are here. We have filled 10. Next what will come? 3s 2. 2 plus 2, 4 plus 6, 10 plus 2, 12. Next, 3p. 12 we have filled, totally 16. So remaining how many is there? 4. In p orbital, can we fill 4? Yes. Maximum it can hold 6. So we are filling 4. So 1s2, 2s2, 2p6, 3s2, 3p4. This is the electronic configuration for sulfur. Okay. Now, suppose if you take copper. For copper, the atomic number is 29. Okay, this copper alone they will ask in 3-mark question. Copper and chromium alone they will ask in 3-mark question. Okay, so how to write the electronic configuration of copper and chromium? That alone will be little bit different. Chromium means Cr. Okay, so copper it is 29. So first which one we should fill? 1s. So 1s2. Next you have 2s2. Then 2p6. 2 plus 2, 4 plus 6, 10 we have filled. Next what will come? 3s2. Next 3p6. And then next 4s2. Now tell me how many is there? 2 plus 2, 4 plus 6, 10 plus 2, 12, 12 plus 6, 18 plus 2, 20. Remaining how many is there? 9. So after 4s, what is coming? 3d. D orbital means maximum 10 electrons it can hold. Remaining we are having only 9. So it will be 3d9. So in short form, we can write this as these two alone. We can write this as 4s2 3d9. But it will not be 4s2 3d9 because how the copper will arrange its electron abhina, from this 2 electron, 1 electron will go here and it will become 4s1 3d10. 4s1 3d10. So for copper, we will not write it as 4s2 3d9. We will write it as 4s1 3d10. Why? Because half-filled shells and fully filled shells are more stable. So in s orbital, maximum how many electrons? 2 electrons. What is the half of that 2? 1. So instead of 2, here 1 is filled. 1 means it is half filled. D orbital maximum how many electrons? 10. Here also 10. So it is fully filled. So half filled and fully filled orbitals are more stable. So the copper will automatically arrange the electrons like this in order to become stable. Okay. So why it is written as 4s1 3d10? Because half filled and fully filled orbitals, half-filled and fully filled orbitals are more stable. So that is why copper we will be writing like this. Similarly, if you see chromium 24, how we will write? 1s2, next 2s2, 2p6, 2 plus 2, 4 plus 6, 10. Next we have 3s2, 3p6, 4s2. 2 plus 2, 4 plus 6, 10 plus 2, 12. 12 plus 6, 18 plus 2, 20. Remaining how many is there? 4 only is there. So 3d it will become 4. So 4s2, 3d, 4. But it will automatically arrange as this one electron will come here. 4s1, 3d, 5. Why? This 1 is the half of 2 and 5 is the half of 10. So here half filled orbitals are more stable. Okay, so it will automatically arrange like this. So it is written like this because half filled orbitals are more stable. So this alone they can separately ask in 3-mark questions. Why for copper and chromium the electronic configurations are written like this? You have to write the actual concentration and then you have to write the correct concentration and then you have to write the reason. Okay, so with this we are completing our structure of atom chapter.